All right, welcome to part 2 of your day 92 area between curves assignment. Hopefully you've had time to try this. If you haven't, you should pause the video, try it, and then if you get stuck, you can come back and skip to the problem you got stuck on. So let's begin. Problem 1. We got some colors here. You'll notice the first 3 problems are no calculator. The last 3 are calculator active, so make sure you have a calculator out for the last 3. I'm just going to color code these quickly. So here's problem 1, and I'm actually going to give you 2 ways to do this one. Option number 1 is to go through and just do a top minus bottom. Now, if you do top minus bottom, you might notice there's this third kind of weird, boring function down here. This is the line y equals 0. So let's think about how top minus bottom would work. So let's do it maybe this way, and we'll say top minus bottom. Okay. Now, if we want to find the area of R, my top function is the square root of x and my bottom function is 0, at least for a while. So I'm going to go ahead and do the integral. Top function, square root of x. Bottom function is the line 0. You don't need to write the 0. I just think it's always nice to see the two functions. Dx. But then what do we integrate from? Well, if we're doing top minus bottom, top minus bottom, top minus bottom, you might notice that after an x value of 4, we switch functions. So I can only find part of the area. I can only find the area from 0 to 4 to begin. Well, how do I find the rest of the area? A couple ways to do it. Option 1 is you can add on a second integral. Notice this integral is going from 4 to 6. Everything's in terms of x here. And my top function is 6 minus x, and my bottom function is again 0. Okay? So let's actually finish this one out. Maybe I'll have to use a little bit more room here. So as we finish this out, let's see, top minus bottom, let's simplify this a bit down. The first one I'm going to have to integrate from 0 to 4. If I simplify the inside, that's just x to the 1/2 dx. And then I have to add on a second integral, but if the integral is just measuring this last little area, let's be clever here and realize that this area is just a triangle. And our triangle has a base of 2, a height of 2, and so I think the area of the triangle should be easy. 1/2 times the base times the height. Okay, continuing out. Antiderivative of x to the 1/2, so add 1 to get 3/2, 2/3 to offset the 3/2 from 0 to 4. Okay. And then we can probably do our area. 4 divided by 2 is 2. That's the area of the triangle, and let's continue it on. All right, so then we end up with, let's see, it looks like 2/3, 4 to the 3/2. We do have to plug in 0, and I guess I should do that. We'll do 2/3, 0 to the 3/2 plus 2. And then we're going to do some mental math here. So let's see, the square root of 4 is 2, 2 cubed is 8. So I'm looking at 2/3 of 8. This just becomes 0 plus 2. And you can continue on if you want, but I'm going to go ahead and stop here. Realize on a free response, you could also stop here. This would be fine. However, you cannot stop here. That's not something you can plug into a blue calculator, a scientific calculator. You need to go a little bit further. Okay, now I said I'd give you 2 ways to do this. One of these was top minus bottom, but using 2 integrals. Well, the other method we've talked about is that left minus right, or that right minus left sort of thing. So if we're doing right minus left, then I think this might actually work a little bit nicer than the other way. So right minus left, we'll do this one in orange. Notice that it's always going to be the green function minus the red function if we go right minus left. So that's actually nice. It's a consistent function. So let's get that integral out. Integral, and then we're going to have to do the green function, which is on the right. Oh, but remember, if we're doing right minus left, our rectangles here are going to have a width of dy, which means that when I do right minus left with dy at the end, each of my functions need to have y's in them. And right now, they don't have y's. So let's do a little bit of math. We'd have to square both sides here. I'll treat f of x as y. So I'm going to get y squared equals x. And then add, let's see, if this is y equals 6 minus x, I can probably add x, subtract y, get x equals 6 minus y. So now I've got 2 functions here. Should have done this in green. So we get x equals 6 minus y. That's the function on the right, 6 minus y. The function on the left is y squared. And actually, this is a way easier function to take the antiderivative of. We don't have that x to the 1/2 doing weird stuff. Okay, but we do have one more thing to take care of, and that's our limits of integration. Notice, because everything's in terms of y, I need to use the y values. The highest y value we get to is 2. The lowest y value is 0, so I need to go 0 to 2. So really, if you just do the antiderivative of negative y squared minus y plus 6, and then plug in 0 and 2, you should get this exact same answer. So honestly, this way is probably faster, and so that's just for you to realize that you should stay on your toes and remember that there's often more than one way to do a problem. Alright, here's problem 2, again assuming you've tried it. We'll do the tangent line first, nothing too bad. So we know my tangent line to f has to have the slope of f at 1/2 times x minus 1/2 plus the value on f at 1/2. Okay? Well, f of 1/2 is easy. They gave us that's 1, which is the graph of f. 8x cubed is one graph, and then g of x is sine. Oh, we should know that this one's sine. It looks like the graph of sine starts at 0, 0. And then 8x cubed, that's a cubic function. They just gave us part of it. And they're being a little tricky here, not telling us which function is which. So let's fill this in. Okay, we know part of this. We know x minus 1/2, and we know f of 1/2, they gave us the point, is 1. That's great, but I think we're missing a slope here. Well, slope-wise, we I think just need to take a derivative and plug things in. So we know that this is to f of x. Here's our f prime of x. And let's see, 24x squared, and then I think we just need to plug in 1/2 and be okay with fractions. Right? Half, a quarter of 24 I think is going to give us 6. So we get 6, and we're done. Now, again, if this was a free response and you were worried about your fraction, you could have left it like this and put that in for the slope. That's totally fine. It's a good way to go in case you ever get lost in all the little arithmetic. But here we go. Let's find the area of R. The area of R here, I think top minus bottom is probably a good way to start. It looks pretty consistent. Green minus red all the way through, top minus bottom, nothing too bad. So let's do it. It says find the area. We need to integrate. Top function is the green one. That's going to be our sine of pi x. And then the bottom function is the red one, which is 8x cubed. Okay, and then we're integrating from an x value of 0 to an x value of 1/2. We know it's x values because everything in here is in terms of x, and our rectangles that we draw have widths of dx, and we know that everything needs to be consistent, 0 to 1/2. Alright, now the fun begins. We have to do the antiderivative to use our fundamental theorem of calculus. So antiderivative-wise, sine is definitely going to become cosine. And then we're just going to play with it until we get the right answer. So the derivative of cosine would be negative sine. There's no negative there, so we need a negative out front. And then the derivative of this pi x, it would stay pi x, but be multiplied by the derivative of the inside, so an extra pi. There's no extra pi there, so something must have canceled it out. So let's just cancel it out. And you can either do that by doing 1 over pi, or to save some space, you could put everything over pi, whatever sounds good to you. Okay, and then the second one should not be too bad, right? Our antiderivative of 8x cubed, well, we need to add 1 to the power, and then 4 times what is 8? 4 times 2 is 8, and then we're going from 0 to 1/2. Okay, let's see, how can we make this a little nicer? I'm going to go ahead and take the negative out of all of this, and then let's plug everything in. So now everything's going to be a positive. You could write it like this if you wanted, but now we're going to plug in 1/2. So I have, I'm going to write the 1 over pi out front now. We have cosine of 1/2, well that's going to make this pi over 2, right? Half of pi, pi over 2, okay, plus, parentheses, plus 2 times 1/2 to the 4th, okay, minus, now we have to plug in the lower one, so we have 1 over pi times cosine 0 times pi is 0, plus 0, okay. And then notice they're going to try and trick you here because they think that you might realize, or think you realize that if you plug in 0, this all turns to 0, but notice it doesn't, so let's be careful. So going through a bit at a time, this becomes 0, cosine of pi over 2 is 0. 1/2 to the 4th is 1/16. 2 over 16, 2/16 reduce. I'm getting 1/8 for the first set of parentheses. That's all 1/8 right there. Minus, well, that's 0. Cosine of 0 is 1. 1 times 1 over pi. I'm just getting 1 over pi, and I think that's probably our final answer. Realize again, for your response, you could have stopped right here, no problem. Oops, and I made a mistake. If I had stopped here, I would have been perfect, but my answer wouldn't have been because I forgot the negative on the outside. Silly, silly. So let's put the negative there, and now we're good. Notice on this one we wouldn't want to do right minus left because we'd have to change everything in terms of y. Now changing this one, the red one, in terms of y isn't bad. You divide by 8, take the cube root of both sides, kind of gross, but changing this one's real bad because you'd have to do inverse sine and then divide by pi, and inverse sine, antiderivative of inverse sine, you'd probably be at a loss. You should get the same answer, but probably not worth doing. Okay, next one. Here we go. There are many different ways to do this one. Maybe challenge yourself to do it in a different way. But I'm just going to keep with our top minus bottom sort of theme here. So we have a top function. Let's see, y equals 2 square root of x. That's going to be the bottom one. It's a square root function. And the horizontal line, y equals 6. And let's get to it. Find the area. We are going an x of 0 to an x of 9. Okay, top minus bottom. Probably need less space there. Top minus bottom, nothing too bad. So top function 6, bottom function is 2 square roots of x. Everything's in terms of x, dx. Those rectangles this way have a width of x, or dx. And let's do our antiderivative stuff. Maybe it'll help you to look at it like this. 0 to 9, 6 minus 2x to the 1/2. Okay, as we go through, we know the antiderivative of 6 is 6x. I'm going to keep the 2 here. We'll play with that later. This is x, add 1 to the power 3/2, 2/3 out front. Okay, from 0 to 9. Or cleaning this up a little bit, hopefully we can see that's 4/3. And then we have to plug in everything. Now, notice that if you plug in 0 to each of these, they'll both turn into 0. So I'm going to save some space and just plug in the 9. It's going to give me 54 minus 4/3 of 9 to the 3/2. It'd be good practice to simplify this, right? Square root of 9 is 3, 3 cubed is 27, a third of 27 is 9, and 9 times 4 I think is 36. So then we have 54 minus 36, and to me that's looking something like an 18 here. Okay. Now, other ways to do it. Notice that you could do right minus left here. Yeah? Right minus left, we could do this green function on the right, and what function's on the left? Well, that's just the line x equals 0. And this one on the right would be, let's see, we divide by 2, so 1/2 y equals square root of x, and then square both sides. So that's going to be 1/4 y squared equals x. So if you wanted to set up a right minus left, we'd integrate. We'd do the right function, which is 1/4 y squared minus the left function, which is the easy function 0. Our rectangles are going sideways now, so everything's in terms of y. And then we have to do our y coordinates. So from 0 up to, well, this y coordinate is 6. And that actually might be even easier than doing the square root. Let's try it. Let's see if we get the same answer. So the 1/4 is irrelevant, but we can keep it there for now. Okay, y squared becomes y cubed. We need a 1/3 to offset the y cubed from 0 to 6. To save you some time, I'm going to factor out the 1/3 and 1/4. That's 1/12, I think. And then we're just going to plug in 6. 6 cubed, right? A 12th. A 6 cubed, I think, does that sound like 216? And then I'm hoping that 12 times 18 is 216. Calculator is around here somewhere. Let's just pretend that's 18. Okay, another way to do it. Is there a third way? I think so. A third way, what if we took this whole shape right here? That's an easy one. That's a rectangle, isn't it? It's a 6 by 9 rectangle. It has a total area of 54. So what if we took that 54 and then we just subtracted off this area right here? And that area right there is the integral from, Well, it's just going to be below this, so from 0 to 9 again, right? 0 to 9 of 2 square roots of x dx. Of course, we actually did that. That's right here, 54 minus this. It's one fewer antiderivatives, but the antiderivative from 6x to 54 wasn't hard, and that would give us the same answer too. So there are your 3 problems without a calculator. Let's get to the calculator active. Problem 4. There's a couple different ways to do this. We already talked about the 2 ways. You could go top minus bottom and then have 2 different integrals, or you could go right minus left. It's actually very, very similar to the one that we did first, but this one is calculator active, the other one was not. And so since it's calculator active, let's get to it. The first thing I'm going to do is I'm going to label each of these functions. So 5 minus x right here, they called it y. I'm going to say let's let g of x equal 5 minus x. And the second thing I'm going to do is this one over here. I'm going to say let f of x equal natural log of x. So that way it's going to help you with parentheses, and instead of having to write out the equations, you can just write f and g. It's going to keep things a little bit cleaner. So let's maybe try it just top minus bottom this way. You could do it with your calculator a different way later on, that's fine, but I'm just going to do it one way. So we're going to go ahead and do the integral. Okay, and let's just do this natural log first. From 1 to something of natural log, and this bottom one I think is 0, right? So this first one is going to be f of x minus 0. So we're going to do f of x minus 0 dx. And then we need to add on our second integral, which is going to be this piece over here. This is going to integrate the function 5 minus x. Oh, but we called that g of x. That's way easier. G of x minus 0 dx. Missing a parenthesis there. There we go, parenthesis. It should be something like that. Perfect. And then from where to where? Well, from 1 to somewhere, and then from somewhere 1, 2, 3, 4, 5, 5, that makes sense. Okay, but how do we find the somewhere? And that's where our calculator comes in handy. We need to figure out where these two intersect. And although you could set up an equation, natural log of x equals 5 minus x, and solve, it's probably a little bit easier to use your calculator. And to do that, we're just going to graph each side. So pull out that calculator. I've got mine right here. And we're going to go ahead and just graph each equation. So I'm going to go ahead and graph the natural log of x. Come on, calculator. There we go. And I'm also going to go ahead and graph the equation 5 minus x. When I graph both of those, notice the shape here should look familiar. We need to find the intersection point. I'm always a fan of using the analyze graph over trace. Analyze graph will record the point. Trace just kind of pops it up there momentarily. So we want their intersection, and it looks like that's going to be 4 right here. And then, my equation just moved, so that was terrible. I wonder if I can do a Control Z. Hey, there we go. Let's try this again. Menu 6, 4. Being very careful this time. Apparently not careful enough. There we go. 1, 2. And dragging this up. Now, this says 3.69. We know that's not accurate enough. We know we need to hit the plus to get more decimals, but then the problem is we're going to have to use that decimal too. So 3.693. I'm going to come back here. This is going to tell us that x is equal to 3.693 dot dot dot, and I'm going to actually let a variable equal that. I'm going to say let a equal 3.693 dot dot dot. So then I don't have to write that gross decimal. I'm going to use a here and a here. But we can actually do that on our calculator too. So I'm going to jump back over here really quickly, and I'm going to go ahead and take that value, and I'm going to do Control and then STO is in blue for store. And I want to, oops, be better than that apparently. I first need to click on this. There we go. It's going to highlight, and then Control store, and it says what variable do you want to store this as? I want to store it as a. Enter, and it will turn bold. So now when I'm back on my other screen and I type in a, it will actually give us the full thing A. And you're like, oh, that's only 5 decimals. Is that accurate enough? Well, if you go up and hit enter on it, it is all the decimals that the calculator will store. It just truncates a bit depending on your settings. So what do I need to do? Well, I need to plug all of this into my calculator. So natural log from 1 to A. Let's see if I can get this all at once. Menu, calculus, integral from 1 up to A. Notice A is bold because that's a variable of, or it's a constant now, no longer a variable, of the natural log of x dx. And then I need to add on another integral. So menu, calculus, integral from A, and I believe it was up to 5. And then our equation was not highlighted, 5 minus x dx, and enter. There we go. 2.9858. If you want the full decimal, because mine is truncating after 4, it's like this, 2.9858. And on your answers, it's probably not a bad thing to go further than 3. 2.9858. I would go at least 4. Your graders will stop reading after 3 decimals, but that way you don't have to worry about rounding or doing anything weird. Okay? Now, these ones should go a little bit quicker. So, here we go. Problem 5. We need to find the area of R. Let's get to it. Area of R. We're again going to do top equation right here, and that's got to be my square root of x equation, and my bottom equation, which is this one down here, e to the negative 3x. Hopefully you understand that we're going to do this the exact same way we did on the last one. So I'm going to go ahead and graph each of those, square root of x and e to the negative 3x, to find their intersection point. I'm going to clear out my graph, delete 3 times. Okay, and so now we have our square root, oops, that's not it, second try. Oh, you stop that right now. So for some reason my pen does weird stuff on this screen, but either way. Okay, so we have the square, third try, the square root of x, and we also have e to the power of negative 3x. There are those two. Notice the region it makes is really, really tiny down there. It's that one right here, and they have this line at 1, but we just need to find that intersection point. So menu, 6, 4, and I want to find the intersection without picking up the graph. Just click, there we go. And we're here, and same thing before. I'm going to go ahead and save that for later use. Control store. I'll just store it as A again. It's going to overwrite the other one. No reason to do anything different. Okay, and then I think to find our answer here, we're just going to have to integrate from A, that's starting right here, over to 1. Now, I'm not just going to use A and 1, I want to explain where A came from, right? So we can just do it somewhere over here. So we'd say square root of x equals e to the negative 3x, and that implies that x is equal to, I don't even remember what A is, 2.239? And with some extra decimals, then I'm just going to let A equal 0.239. There we go. So from 1 to A, top function is going to be my square root of x, bottom function is going to be e to the negative 3x, and we have to do dx, and we'll get our answer. Remember, you can't just write an answer on this problem. You always have to show a setup for a problem and an answer. How you get from the setup to the answer is on you, but they expect a setup and an answer. So finishing this off quickly, it looks like we're going to clear off this line. We need to do menu, and then calculus, integral. We're going to go from A at the bottom up to 1 of, and just for fun, I'm going to switch the order of these. We're going to do e to the negative 3x, tap and right, minus, and then my other one was the square root of x. And think for a second, what's going to happen if I switch the order? Well, when I hit enter, I get a negative answer because now I'm doing bottom minus top, and when you do a small y value minus a big one, you're going to get a negative every time. And so the nice part is I don't even need to redo this. I know the answer is the same. It's just positive 0.442, 0.4426, I think. So we're going to get 0.4426 as our answer, and we're set. Okay, last one. couple things. First, we need to show that L is tangent to the graph of f of x at x equals 3. Well, tangent lines do two things. They have to contain the same point at x equals 3. So let's make sure they both have the same point. Okay, so we're first going to find, and I should do these in colors again, so we're going to take f of x to be this one in red, and we'll continue on and let the line look like that right there. Easy enough. Okay, so I'm going to go ahead and first prove that f of x and y of x have the same y value at 3. So f of 3 is just going to be 4 by, ooh, I don't like that equation at all. Maybe we should factor this first. I'll take out, let's switch the order, so I'm going to call it negative x cubed plus 4x squared. Then I'm going to factor out an x squared. I like this a little bit more. Maybe I'll factor out a negative x squared. Really go big here. We get x minus 4. I think that looks pretty good. Okay, so f of 3 then is going to be negative 3 squared by 3 minus 4. Much easier to evaluate things in factored form. Negative and a negative is positive. I'm getting positive 9 here. And if I did everything right, then when I take my green function and do y of 3, evaluate 3 in here, 18 minus 3 by 3, 18 minus 9 is 9. So they do contain the same point. That's important. But there are many lines that go through that contain the same point. For example, that line contains the same point. So beyond containing the same point, what do these two lines need to contain? Well, they also need to have the same slope. That's the whole point of a tangent line. At the point of tangency, the line and the graph have the same slope. So let's find each of their slopes. In order to find the slope at 3 for f, we're going to have to find f prime of x first. I'll go back to the original equation for this. That's going to be 8x minus 3x squared. And then I'm also going to have to find f prime of 3 to check its slope. So that's going to give me 24. Let's see, 3 times 3 is 9, times 3 is 27. 24 minus 27 looks like negative 3. And just checking, the graph is going in a downward direction there. Negative 3 seems like a possible slope. Then let's do the same thing for y. Y prime is just going to be negative 3. So when I do y prime of 3, the slope is a constant, negative 3. They have the same slope. Great, we've shown that they are tangent to each other. Same point, same slope. All right, now on to part 2. Find the area of S. This one's actually a little tricky. And the reason it's tricky is just figuring out how we want to set this up. So area of S is going to be this whole area inside. And the reason that's tricky is because if you do top minus bottom, the green function is on top, which seems fine. Top minus bottom, top minus bottom, top minus bottom. Uh-oh. First it was green minus red, but now once we get over here it's green minus just the x-axis. So what do we do? Well, my first thought might be, let's try right minus left. If you do right minus left, notice the green is on the right every single time, which is great. Except if you took your f of x equation, and I'm going to rewrite this as y for a second, 4x squared minus x cubed, in order to find what this equation is to go right minus left, we need to solve this equation for x. And this is really tough to solve for x. I think, in fact, you probably won't be able to solve this for x too well. So since we can't isolate x, there's two different x's here, right minus left is really out of the question. So I think we're just going to have to break this down into two shapes, where this is going to have to come right here, right? And now I have two regions. Maybe I'll call this S sub 2, and this region is S sub 1. So S sub 1 is just going to be my integral from my starting x value. Oh, we found that. That's already 3, right? From 3 to my ending x value. Well, the ending x value, you could graph this on your calculator, but since I already factored it up here, can you see the ending x value? It's got to be 4, right? That's your x-intercept. So I'm going to go from 3 to 4. My top function is the green one. That's my 18 minus 3x. And my bottom function, well, that's the red one. And the red one I'm just going to call f of x to save some time, dx. That's my first area. Okay. Then my second area, well, that is just a triangle, isn't it? You could do green function minus 0, but let's just use our triangle skills. Where does the green function cross the x-axis? Well, if you set this equal to 0, 18 minus 3x, subtract 18, divide by negative 3, I think you'll see this crosses at 6 right here. So I've got a triangle with a base of 2, a height of, 4, Well, maybe this is too much effort, but we're going to plug 4 into our equation here. 18 minus 12 is 6, a height of 6 then. So I've got a triangle that's going to be 1/2 base of 2, height of 6, half of 12 is 6. Easy enough. Okay, then we just put it all together. So my total then is going to be S1 plus S2, where S1, we'll need a calculator from that, or you don't have to use a calculator, but it's probably easier. So we're going to go menu, calculus, integral. We're going from 3 up to 4, and then we had 18 minus 3x, good, minus, and then what was f of x? F of x was our 4x squared minus x cubed, 4x squared minus x cubed, good, dx. And then I'm going to hit enter. Ah, but we got a negative answer. Well, we shouldn't get a negative if we do top minus bottom, so what did I do wrong? Hopefully you saw it as I was typing it out. Well, the issue is I had sloppy parentheses. I don't want to just subtract 4x squared. I need to subtract this entire quantity. So we need an extra set of parentheses right, stop moving, there we go, right here. So that way it shows that we're doing our first function minus the entire second function. Otherwise, you will not get your right answer. And there is my 23 over 12, 23 twelfths. So 23 over 12, and then we can get our final answer. 23 over 12 plus 6. You can simplify if you want or not, but either way, be careful with those parentheses. We need to distribute the negative to everything. So hopefully this was helpful. Make sure that you get this assignment turned in on Teams so I can give you credit for today. Thank you for attending our virtual AP Calculus class.